So thank you. I am Théo Perrin, and I will talk about an active approach to assess perceived speed error during walking and running in virtual reality. Recently, the field of sport and fitness turned to VR to create sport-specific application at the confluence of physical activity and gaming. So it is now possible to make your own training in locomotor activities like rowing or cycling in virtual environment. This training approach could help athletes to enhance motor resources as well as motivation and adherence. A main challenge is to create an efficient natural training tool close to real-world performance. And for running, it means that we need to provide a natural immersive feeling, especially coherent perception of speed, and thus congruency between self-motion cues. For motion speed perception, there is three types of sensory feedback which can provide information. First of all, the dynamic visual information provided by the eyes, called optic flow. Then the proprioceptive information provided by receptors in muscle and tendons. And then vestibular information provided by the inner ear. In the previous literature, it has been reported that the optic flow speed is underestimated compared to actual locomotion speed. It means that when optic flow speed and locomotor speed matched, people usually perceived optic flow speed to be slower than their actual locomotion speed. For example, in the first figure in Benton's study, they asked participants to walk on a treadmill using a HMD and to report if they feel the optic flow speed to be slower or faster to best match their walking speed. Participants in this study were grabbing, as you can see, a crossbar. In the second figure, the recent study of Kerhervé asked participants to run and to evaluate the speed motion perception in front of a large screen. And both of the experiments proposed to determine then an optic flow multiplier, again, to correct the optic flow speed. These results could be related to the underestimation of egocentric distance judgment. However, recently, Moller or Richardson studies show that an interaction phase could correct this misperception in distance judgment. Therefore, the aim of our study is to assess the error made in the perception of speed in VR using an inactive approach. And three main features which differ from previous study. First, the use of HMD device with a large field of view and stereoscopic vision, and a free locomotion on the motorized treadmill. Then, this study relied on a large locomotor speeds from walking to running, and we gave the control of the optic flow speed to the participants, considering the theoretical framework of an action. So, brief definition, we can define it as a form of knowledge gained by doing, gained by the interaction between the participant and the environment in the virtual environment. So for the method, we had 16 participants with a normal or corrected to normal vision, and they were all naive to the research topic. They ran on a motorized treadmill, ran and walk, and they were wearing an HTC Vive. As you can see in the figure, we created an infinitely repeating virtual racetrack with a ground texture and columns placed at large intervals. Then, for participant safety, we created the handheld portion of the treadmill and we collocated it with the real one, so participants were free to run without touching it. And then a blue cube placed at the top of the crossbar and middle of the track for helping tall people to perceive the presence of the crossbar and to run without touching it. So participants walked and ran 17 randomized trials from 3 to 11 kilometers per hour. And they were grabbing a Vive controller to modify their optic flow speed. Each pressure on the trigger lead to 0.02 km per hour increment or decrement, and holding the trigger accelerated the process. There were no time limit to check the optic flow speed, and they were free to adopt their preferred pattern and gaze in every direction. And then we asked participants to answer a 7-point scale questionnaire to know their background. So we asked, what is your experience in running? What is your experience on running on a treadmill? And what is your experience in immersive technology? So for the result, the group rise speed error, we found a good overall estimation of the optic flow speed. So in the figure, we plotted the regression line of the optic flow speed, and it's very close to the locomotion speed, which is the reference speed. Then we split trials between walking speed and running speed at the preferred transition speed, which occurs generally at 7 km per hour, and we found no differences between walking and running. So overall, our results are in contrast with the previous literature, with the global eye assessment of precise speed of both walking and running speeds. However, despite good overall results, we observed that there are important differences between participants. So we plotted the speed differences for each participant. And we saw that some participants underestimated the optic flow speed, like other studies, and some other overestimated it. So we tried to know if this variability was due to participant background. So the answer is no, because we found in the questionnaire answer an homogeneous group with a good experience in running, but not in running on a treadmill. And they were all novice about immersive technology. So regarding this large inter-individual variability, we think that the use of a unique optic flow multiplier is not appropriate to correct the optic flow speed to appear normal for participants. That is why we must calibrate it for each participant. So in the second part of the article, we tried to determine the best way to set up the optic flow speed. I will be brief about that. So we tested 3 mathematical models, and the use of the linear model appears the best to use. First, because it's simplicity. So you only need 2 optic flow speed values, one from walking and one from running, to calculate the gain. And secondly, it was accurate to represent the optic flow speed and locomotion speed relationship. So our results are in contrast with the speed underestimation consensus, and we made some hypotheses to better understand this difference. First, in the nature of the experimental setup and virtual environment. So it could be due to a better perception of space, due to stereo vision, visual quality improvement, or columns placed at the regular intervals. Then participants, unlike previous study, were free, had a free locomotion, so they didn't touch the crossbar, and they had a larger lamellar flow due to a larger field of view, and ground texture. And then the use of the interaction between the participants and the environment may have conducted to a better rescaling or calibration. So we demonstrate that a different approach of motion speed assessment could lead to a better speed perception. However, we still need to investigate the impact of the experimental setup and virtual environment for the accuracy of motion speed perception, as well as the importance of the enactive approach. So to go further, future projects will investigate the role of virtual environment feedback on the subjective and objective performance of the athletes. Thank you for your attention.
Well, thank you. Are there any questions for Théo? Too early for you guys? Okay, so I have one question, is about the virtual environment that you used. You add, in fact, textures, but there are no, let's say, known features whose size would be pretty much known and that would look familiar to and help people to get more information about metric information.
Yeah. So we didn't want to use very familiar cues for the participants. However, the ground texture led to a better perception of the optic flow, and as well as the column placed at the regular intervals.
Yeah, we don't know the distance.
10 meters between the columns.
Yes, but does the user know them, the subject?
No, no, no.
Please. Could you introduce yourself first?
Sure. Pablo Figueroa, Universidad de los Andes in Colombia. The changes in speed that you were trying with the gamepad or touchpad, were they continuous, or it was how was the change of the speed?
When participants press the trigger, the speed just change to from 0.02 kilometer per hour, so just a click, and then if you hold the trigger, it accelerated. So it was pretty easy to go up or go down with the trigger.
And what about cyber signals related to that change?
We didn't found any problems with cyber sickness. It was quite smooth to go up or go down, and the acceleration was not very high.
Okay, thank you.
Hi, I'm Project from Roskilde University in Denmark. I have just a, clarificatory question. How important do you think is like in terms of the nature of interaction that your system had, was like more like clicking and the button, probably the round button on the HTC Vive controller?
It was the pad of the Vive controller.
Yeah. So how important do you think it is to to decide on the nature of interaction as an intervention? Because normally when you use the term inaction, it's like more embodied and more like body-based interaction. I mean, of course, every interaction is body-based, but this was quite minimal, and I'm not sure if inaction would be like the best way to...
I don't know if it's the best way, but in future works, we want to evaluate the impact of the inactive approach. So we can maybe try different methods and compare them. But for now, it was the first ID and just an ID. But we can try to determine better way to do that. Yeah.
Okay. Thanks.